Hello everyone. Let us discuss about methods of preparation of carboxylic acids. You have seen methods of preparations of carboxylic acid in previous lessons. While writing reactions or synthesis of alcohols or aldehydes or ketones, we gone through some of the preparative methods of carboxylic acids also, right? From alcohols or from aldehydes, oxidation reaction, right? In oxidation reaction, we have studied oxidation of aldehyde to carboxylic acid, oxidation of alcohols to carboxylic acid, etc. Now, let us discuss more reactions of or more preparative methods of carboxylic acids in this lesson. First one is from primary alcohols and aldehydes. From primary alcohols and aldehydes. How can we prepare from primary alcohols? As we studied, alcohols which on oxidation, right, in presence of potassium permanganate, in presence of acidic media, basic media or neutral media, it will oxidize us to corresponding carboxylic acids, right? And or in presence of a chromic oxide or CrO3 trioxide, but in presence of a sulfuric acid or any acidic media, these alcohols, primary alcohols will convert into carboxylic acids, right? That is RCH2OH, primary alcohol, in presence of alkaline potassium permanganate KMnO4, first one. Second one is acid hydrolysis. Hydrolysis is in presence of water, H3O plus represents acid. Hydrolysis will result in the formation of corresponding carboxylic acid, right? Or we can prepare carboxylic acid on reaction with the chromium trioxide also, right? How? That is larger carboxylic acid, CH3, CH2, 8 and COO, H1, 8, 9, 10, right? Sorry. CH2OH, decanol. Decanol on reaction with chromium trioxide, and as I said, it is reacts in presence of acid media, that is in presence of sulfuric acid, mineral acid, right? You know, right, difference between mineral acid and organic acid. What are mineral acids? Mineral acids are nothing but containing hydrogen and sulfuric acid, HCl, HNO3 are called mineral acids, and carboxylic acid or organic acids containing a carboxylic functional group, right? This is about preparation of a carboxylic acid from alcohols. And from aldehydes. Aldehydes, we all already studied that mild oxidizing agents like Grignard reagent or Felling's solution, right, gives carboxylate ions which on hydrolysis will get carboxylic acids, or in presence of oxidizing agents like MnO4 or HNO3 also leads to the formation of carboxylic acids, right? From alcohols, it requires some strong oxidizing agent. As we know, alcohol to aldehyde or ketone, aldehydes or ketone to carboxylic acids, right? This is about preparation from primary alcohols and aldehydes. Next is from alkyl benzenes. Second preparative method from alkyl benzene. Okay. Aromatic carboxylic acid can be easily prepared by using alkyl benzene. How can we prepare aromatic carboxylic acid using alkyl benzene? From the aromatic or benzene ring containing alkyl group will convert corresponding carboxylic acid irrespective of the length of the alkyl group. Okay, that is oxidation of alkyl benzene with the chromic acid or acidic or alkaline potassium permanganate gives a corresponding carboxylic acid. Okay, oxidation of alkyl benzene in acidic or alkaline or basic. Alkaline acidic or alkaline chromic oxide, chromic acid or alkaline potassium hydroxide leads to the formation of a carboxylic acid. And one thing you must remember is irrespective of length of side chain. Okay, irrespective length of the side chain. For example, toluene, alkyl benzene, right? In presence of potassium permanganate and potassium hydroxide alkaline media. First, it will convert into salt of corresponding carboxylic acid, that is potassium salt of corresponding carboxylic acid, which on acid hydrolysis results in the formation of a corresponding carboxylic acid. This is about preparation from alkyl benzene. And one more example, as I said, irrespective of the side chain. If it is CH2, CH2, CH3, okay, long chain is there, and in presence of KMnO4 and potassium hydroxide alkali, it results in the formation of a potassium benzoate COOK, which on acid hydrolysis leads to the formation of a what? Carboxylic acid. Right? This is about preparation from a alkyl benzene. Next is from nitriles and amides. So, nitriles will, in first step, nitriles will result in the formation of in presence of acid will result in the formation of a amide which on acid hydrolysis gives a corresponding carboxylic acid. Third one, from nitriles. or amides. Here nitriles hydrolyzed to corresponding amides. And amides in presence of acid, that is H plus or OH minus, leads to the formation of a carboxylic acid. Then two acids in presence of H plus or OH minus. Okay, these are CN in presence of H plus or OH minus hydrolysis. It results in the formation of amide. Amide in presence of H plus or OH minus on heating gives a corresponding acid or COH and ammonia. Okay. Or we can directly convert amide into corresponding acids, that is like by maintaining mild reaction condition. Okay, we can stop, or by maintaining mild condition we can stop the reaction at the amide stage. Here we can stop the reaction, we will get amides instead of a carboxylic acid. Amides on reaction with the acid hydrolysis, directly will write, gives CH3 COOH plus NH3 acetic acid. Or benzamide in presence of H3O plus, right, acid hydrolysis, benzoic acid, right, benzene ring and COOH plus NH3 as a byproduct. This is about preparation of carboxylic acids from nitriles and amides. Next is from Grignard reagent. That is fourth one, from Grignard reagent. So we know Grignard reagent, that is RMGX, right? Alkaline magnesium halide are called Grignard reagent. See, Grignard reagent reacts with carbon dioxide, solid carbon dioxide, to form salts of carboxylic acids, which on acid hydrolysis gives a corresponding carboxylic acids. Okay, I'll write the reaction. RMgX on reaction with the carbon dioxide CO2. As we know, MgX part is electropositive, it is positive end, and here it is a negative, right? Partial positive and it is a partial negative, not electropositive. Partial positive acquires partial positive charge and R acquires a partial negative charge. Now what happens is R come and attack over this carbon and bond shifts like this, and which will result in the formation of a RC to this carbon. R group is attached and remaining is C double bond O and O minus. O minus and C double bond O will write here and O minus. Now O minus will react with the MgX. It is partial, acquires partial positive charge and hence it becomes a OMgX. This is partial charge part, it is partial positive, here it is partial negative. Neutralization takes place, right? Next, which on acid hydrolysis, that is H3O plus acidification with mineral acid gives RCOOH plus this will here RC double bond OH and remaining is MgOHX. You can write or no need of writing. Okay, so left to you, and that you are knowing how to write the product there. This reaction will take place in presence of a solid ice, carbon dioxide is called a dry ice. Okay, this is called a dry ice. You know about a dry ice. So solid carbon dioxide in presence of dry ether. Okay, carbon dioxide is called a dry ice. So we can use this reaction, third reaction, that is from nitrile and from a Grignard reagent. By these two reactions, we can convert directly alkyl halide to carboxylic acids. As we know, we can prepare alkyl nitriles and nitriles RCN and Grignard reagent from alkyl halides. Okay, we can prepare these two from alkyl halides. So that from alkyl halides this reaction is nothing but conversion of alkyl halide to corresponding carboxylic acid. But thing is, if there is one carbon atom in carboxylic acid, there will be two carbon atoms. So double the number of carbon atoms present compared to that of alkyl halide. Okay, so in between we can convert this as nitrile and Grignard reagent. From that we can convert into carboxylic acids, right? Next is from acyl halides and anhydrides. Fifth one, from acyl halides and anhydrides. Acyl halide or acid halides or acid chlorides, which on hydrolyzed with water in presence of water directly converts into corresponding carboxylic acids. Okay, but in presence of OH minus, that is base, or in presence of aqueous base in presence of water, it will convert into corresponding carboxylate ion, and further acidification gives a corresponding carboxylic acid. Base, aqueous base will result in the formation of RCOO minus, that is carboxylate ion formation takes place, and Cl minus, that is HCl or RCOO minus, HSA mode, and here there is a Cl minus, which on acidification, acid hydrolysis, see H3O plus acid hydrolysis or acidification of that results in the formation of a corresponding carboxylic acid. This is about preparation from acyl halides or acid halides. Now, how can we prepare from corresponding anhydrides? Oh, it's an anhydride, right? Gives two molecules of benzoic acid, C6H5COOH. Okay, that is benzoic anhydride or C6H5 C double bond O. We can write the structure like this, and here CH3. This also we can write like this. Okay, that is benzoic ethanoic anhydride, which will give on hydrolysis C6H5COOH plus CH3COOH. This is nothing but C6H5COO, C double O, here COCH3, this one, right, which on reaction with water gives a corresponding carboxylic acids. This is about preparation from acyl halides and anhydrides. Next is from esters, that is sixth one, from esters. In many classes I have mentioned this reactions of esters. As I said, acid plus alcohol always gives a ester, right? Acid, alcohol gives a ester. So if we, this is reversible reaction, right? If we hydrolyze ester, it results in the formation of alcohol and acid, right? This reaction you must remember always. Acid, this is called esterification reaction, right? There is acid, alcohol, ester. It is called hydrolysis of ester, gives alcohol and acid. So esters hydrolysis in acidic media directly give carboxylic acids, but in basic media results in the formation of a salt of carboxylic acid, and which on acid hydrolysis or which on acidification gives a corresponding benzoic acid or a corresponding carboxylic acid. That is acid hydrolysis of ester. That is, in presence of acid, esters, I'll take one example, C double bond O. If it is H, carboxylic acid, and if there is R group, then are called esters, right? R C double bond O, OH carboxylic acid, OR, C double OR alkyl groups, then are called esters. Right? In presence of acid, that is acid hydrolysis and water, it results in the formation of what? Corresponding carboxylic acid and alcohol. Right? And as I said, in basic media, it results in the formation of CH3, CH2, CH2, COO, C2, H5 is given in your book. That only I will take. In presence of sodium hydroxide, that is a base, what will get? It results in the formation of a corresponding carboxylate ion or a salt of carboxylic acid. C2H5OH. And which on acidification gives a CH3, CH2, CH2, COO, H and alcohol acetes. Right? This is about a preparation of a carboxylic acids from ester. That is, so far we learnt about preparation from alcohols or aldehydes. That is the first preparative method. And second preparative method, what we have studied is from alkyl benzene. Next is from nitriles and amides. And after that, from Grignard reagent, from acyl halides and anhydrides, and from esters. Thank you.